Right. Good afternoon and welcome to everyone who's online and those of you who have been on earlier and listening to some of the conversation between myself, David, and the organizer of the SIMM. Welcome. You've heard some of the background stuff. So my name is Gordon Smith. I'm a past president of the Southern African Institute of Mining and Metallurgy. I serve on council and a founder member of the Environmental, Social and Governance Sustainability Committee, the ESGS Committee. And I'll be the moderator for today's session. And we're going to focus on a single topic, that of decarbonisation, an overview of the practical steps being taken in the mining industry. It's going to be presented by David Pearce, who's on screen as well, of SRK Consulting in the UK. However, before I introduce Dave, I'd like to set some context. So in 2021, recognising that mining is an energy-intensive business, the ICMM and its members, representing about a third of the global mining and minerals industry, committed to undertake one of the most ambitious programs of reform ever attempted. That is to achieve net zero scope 1 and 2 emissions by 2050 or sooner. Certainly an ambitious goal. A few years later, many of the mining companies also set targets to reduce greenhouse gas emissions by 30% by 2030. In this webinar, David will give an overview of what companies are doing globally to achieve these targets, talk about how setting these targets is helping to reduce operating costs, and comment on how companies are evaluating initiatives. He'll spend about 30 to 35 minutes working through his presentation, and then the session will open up for discussion of your inputs. So please put your questions into the Q&A tab, not into the chat tab, put it into the Q&A tab, which will then be monitored by the SAIMM team and myself. When David is finished, I'll work through the questions, aggregating as necessary, and we'll try and address all the queries before the end of the session. So, to formally introduce David Pearce, as a principal mining engineer, has more than 35 years of experience in open pit mining operations. He spent 11 years on world-class mining operations, both coal and hard rock, before joining SRK Consulting in the UK. David has worked in a wide range of commodities and working environments and is currently a leader of SRK's initiative to help clients develop effective strategies for reducing greenhouse gas emissions. He draws on his experience designing trolley assist and crushing conveying solutions, operational efficiency, and methane capture to help clients identify potential solutions and the likely impact on emissions and project economics. David is well respected in what he does, and I thank him and SRK for preparing and sharing this presentation with us. David, it's all yours now. Thank you. I'm going to switch off my camera.
Thank you very much indeed, Gordon. So let me just bring my presentation up. So good afternoon, everybody. As Gordon has introduced, I'm a mining engineer. My focus here is going to be talking very much about the practical steps. I'm not here to talk about the theory, and I hope that what I'll be revealing is going to be of interest and of use to you. So what am I going to cover? So first of all, I'm just going to give a bit of an introduction about greenhouse gases, talking a bit about the trends, the politics at the moment, and then dive into actually the steps of being able to reduce those emissions. I'm going to borrow from the African proverb, how do you eat an elephant? And the answer is one bite at a time. So I shall walk through what I consider to be the main bites which help companies reduce their emissions. I'll then give an overview of some of the corporate strategies so you can see this in practice, and then wrap this all up. My intention, I'm going to be going through about 40 slides. I'm going to go through them relatively quickly. My aim is to have a lot of information available, but I won't go through all that information. It's going to be available for you to look at a later date as necessary. So greenhouse gases are what keep the Earth at a pleasant temperature. Obviously, water and carbon dioxide have been around and methane have been around forever. And now the question is how much of that is around. Now, the water vapor obviously is fine, but the increase in the carbon dioxide, methane, and then some of the man-made products such as the fluorocarbons, these impacts are causing global warming. In the graph on the left, you can see how carbon dioxide concentrations have varied over the last 800,000 years. So as you can see, there's obviously been a regular variation, but in recent years, we've now stepped out of that variation to something quite new. In the graph on the right, this is showing where the carbon dioxide is coming from and where it is going to. So the various sinks, so the land sink is going back into vegetation, which is good, but the ocean sink is going in as carbon dioxide is being absorbed and acidifying the ocean, and the atmosphere is going into the global warming. So that's where we are in terms of the numbers. We are in interesting times in terms of the politics. There's a lot of changes going on, whether it is through the changes of political priorities, whether it is through increased competition and therefore companies needing to rethink what they can afford to do which have longer term benefits as opposed to shorter term benefits, and whether the politics are rewarding people for taking noble solutions. But there's also a lot of steps, such as the International Financial Reporting Standards Committee is requiring companies to report on the opportunities and risks associated with climate-related disclosures. So they need to talk about how climate change may impact their business going forward. And there's also been significant investment by, for example, in this case, China, in renewable energies, where they are moving away from coal, and the trend towards renewable energies for a country that scale is quite significant. I'm sure many of you know the various definitions, but I'm just repeating it for those who are less familiar. So scope 1 is what happens on site. Scope 2 was what happens off site, but you use for example, electricity there. And scope 3 is what happens either upstream or downstream. The main focus is going to be on what people can control, which is mainly the scopes 1 and 2, but I will touch on scope 3 as necessary. So there are several greenhouse gases, CO2 being the main one, and that's the one that we often convert things back to. Methane is another significant one, and what I'd like to draw your attention to is how much of an impact it has in the short term. So here we're showing the global warming potential, so over 20 years, 100 years, and 500 years. So you can see the methane going from about 80 times CO2 to 30 and down to 10 over time. But obviously, if we can have an impact on the methane in the short term, then it has a big impact on the warming. And then the other commodities, which also have very big impacts, but unfortunately, they only represent about 5% or so of the impact. So main focus will be on CO2 and methane. The mining industry is energy intensive. We all know that. And also turning ore into metal is also energy intensive. So here are some facts and figures to help understand what the impacts are. So as far as the amount of energy we consume, it's about 8 to 15% of the total. About 9 to 12% of the methane released from man is coming from coal mines, and smelting is the principal generator of greenhouse gas emissions. So obviously we have a significant impact, and as Gordon said, in 2021, the ICMM the members of the ICMM recognized that they had a significant role and announced that they were going to try and tackle their contribution. So back to our elephant. So, it can feel like a daunting task. We've got to have big change to do. And how do we do it? If it's too big, well, why should we start? So I'm going to try and break that down into a series of bite-sized chunks so that everybody can see how we can make good progress towards that goal. I'm going to start off with the utilization of low carbon electricity, so renewable nuclear power. So the great thing about this particular bite is the fact that the operations do not need to change any of their processes. All the change is occurring off-site, and it has a significant impact. In many cases, companies can just sit back and wait for somebody else to do the changes because many of the grids are making these changes. Or companies can be proactive and they can either build their own facilities or they can sign power purchase agreements with companies providing renewable power. And there have been some very significant investments or commitments in these parts by companies. I know a number of people who say yes, but renewable energy, but the sun doesn't shine, the wind doesn't blow, so why should we rely on that? Well, here are some examples from the UK grid, starting off with a daily variation on the left, annual variation in the middle, and then the trend since 2012. Yes, when you go to renewable energy, you're going to need to have a flexible system. Well, grids have always needed to be flexible anyway. So coal, nuclear have always been baseload powers, and the flexible one has largely been gas power. So this is still going to be very much necessary. And one of the other factors that needs to be considered is you need to have a lot of backup power for when the renewable energy is not available. However, the trends are at the moment, a lot of the major countries are moving towards being able to generate more than half of their electricity from renewable energy. So it is a significant factor. And renewable energy is actually the lowest cost producer. So this is the levelized cost of energy. So Lazard, a company in the States, they have compared what is the cost of electricity, taking into account capital investment, taking into account operating costs, and then bringing these back down to a single discounted value. So as you can see, the onshore wind and solar photovoltaics are now the cheapest sources of electricity, and therefore a grid system which is underpinned by these has the potential to have the lowest cost electricity. I say the potential because there's more factors. There is going to be a need to have the cost of having backup power included, and it also depends on what that backup power is. So in the UK, as an example, our backup power has been gas, which was fine up until the Ukraine crisis, and then it has meant that we've been more exposed to that particular cost. But as the amount of power from nuclear, from renewable energies, as well as from other countries increases, then that is going to be less of a driver, and therefore the cost will come down. So in the long term, renewable energies will reduce the cost of electricity. Moving on to bite number 2, improving efficiency. Everybody wants to improve efficiency. Everybody has been working towards this. This is still an area of opportunity, and obviously by improving efficiencies, you reduce your energy consumptions, and therefore you can reduce your emissions. The areas that I see opportunities at the moment is in areas which do exist in plain sight. I see that a lot of companies don't have a full awareness of what is happening, and there are a lot of sensors and systems available which provide details which are available for people to analyze. So there's a lot of opportunity still to improve efficiencies and thereby reduce emissions. Bite number 3. So one of the biggest sources of greenhouse gases is the diesel in the transportation, so in your trucks and so especially. So switching over to other solutions is going to have a significant impact. So whether we go for conveyors, trolley assist, batteries, or hydrogen fuel cells, these require low emission electricity. Otherwise, you're not really reducing your emissions. Whilst renewable diesel, unfortunately, is a limited scale, and therefore the opportunities to use this are going to be quite limited. Also, moving to some of these technologies is going to require some new thinking, especially with the mine design and mining sequences. Let me go into some of these technologies for those people who are less familiar. Trolley assist. I found that a lot of people don't understand how trolley assist systems deliver benefits. The key point is that the wheel motors in these trucks are more powerful than the engines, and therefore there's an opportunity if you can utilize that power by sending the power from a grid directly into the wheel motors, then the wheel motors can drive the vehicle uphill up to 80% faster. So as a result, that reduces cycle times and improves the efficiency significantly. In addition, it obviously eliminates the main reason or the main consumption of fuel by removing this work. So this is an area which has got significant potential. Conveyors, similarly, one of the advantages of a conveyor system is that they are inherently more efficient because there's less dead weight to be moved. Now, obviously, if you're also conveying waste, you're having to do extra work with the crushing, but quite often the amount of crushing that's needed, because you only need to bring things down to about 300 mil, is not that significant, and therefore the amount of extra energy in that is not significant compared to hauling out of a pit. So here's a simple comparison for a 200-meter deep pit with an assumption that this is 50% of the electricity is generated by renewables and 50% by gas. So as you can see, yes, the renewable, going for a conveyor system does require more capex, but it reduces the opex, whilst trolley is similar in the capex, but much lower in the opex. And as you can see, the impacts on the CO2 emissions are quite significant. As I mentioned, going for a crushing system or trolley assist may require changes in the mine plans. So in the image here, I've got a typical set of cutbacks where you'd mine the blue first, green second, etc. And the challenge there, if you're putting in a conveyor or trolley assist, is which wall do you put it on, or how do you move it from one wall to another? Well, one option is to change the mining sequence so that you combine the mining so you get to the final wall sooner. So here we are combining on the long wall to be able to put trolley assist or a conventional system in. And here we are on combining at the short wall. So obviously this varies from site to site. But the key point is that if you're adopting this, there will be a need to evaluate the what is going to be the impact on the mine design, schedules, etc. So it's not difficult. I've done this many times, but it does require some additional thinking. Very pleased to have Gordon as hosting this because obviously one of the key initiatives coming out of South Africa was the first hydrogen fuel cell truck at Mogalakwena. So that demonstrates a big opportunity to use existing trucks, so your existing electric drive trucks, to be able to run on hydrogen or hydrogen-rich ammonia as a fuel. So Anglo American was not the only company. So Fortescue in Australia has also commissioned a leap year truck to run the same. So these systems require a combination of excess or lots of electricity as well as lots of water to be effective. Battery vehicles are also making a significant development. Now, the amount of change that is going on in this area is phenomenal. So starting with the ICMM's declaration in 2021, the mining companies have agreed to invest significant amounts of money with the different mining equipment suppliers to help them develop battery electric vehicles. And as you can see from the image on the bottom left, from 2022, they developed a prototype, and then they're going into pilot vehicles are now in the field being operated with the intention that there will be fleets of 30 of these vehicles to several suppliers from 2027 onwards. So those of you who've been in the mining industry a few years will know that this sort of rate of development is quite phenomenal. And it's not just Caterpillar, it's also Komatsu, Hitachi, and Liebherr, and several other vehicles. So there's been significant investment here. However, it's likely that for these vehicles to work effectively, because going uphill is a lot of effort, at the moment, it's likely that you would need to recharge the batteries every 1.5 to 2 hours, as opposed to refueling daily as the current requirements. So therefore, it is quite likely you'd be wanting to link a battery truck with a trolley assist system in order to be able to have the trolley take the heavy work up and then use the downhill journey to regenerate, but also to provide the option of providing charging on some of the flat hauls, so that way the batteries can be kept topped up. Fortescue are also looking to develop a 6 megawatt charger, which can then recharge these trucks in less than 30 minutes. So that's a little bit more than your supercharger for anybody who's driving a Tesla. In terms of which technology is likely to be adopted, batteries are currently more efficient. However, there's a lot of advantages for the hydrogen solutions, and it all depends on whether there is plenty of either hydrogen available from the different sources, or whether there's plenty of a surplus electricity, because the sun does shine quite a lot in a number of places, and why not use that electricity to convert into hydrogen, which can then be stored waiting to be used. Moving on to bite number 4, different technologies, especially with ore sorting, comminution and leaching, are areas where they have significant potential to reduce the amount of energy required, and therefore by reducing the energy, reducing the scope 2 emissions, especially in countries where they've got the electricity is being generated mainly by coal, such as in South Africa or the United States. So these technologies are advancing quite strongly and are being used by a number of companies. The underground operations have used electricity for many years, whether the vehicles have been tethered or whether it's been battery power, and this is advanced further still. With a lot of the underground trucks and LHDs available with detachable batteries, so that you can drive up, change the battery, and then drive on. So that is an area which is evolving quickly, and the underground space is quite advanced in this. Also linking in with being more sophisticated with the ventilation is helping to reduce the costs. And then, of course, rethinking things and deciding to have your process plant located underground, so you don't need to lift your rock so high. And if your tailings are still being placed underground into backfill areas, then of course it doesn't need to come downhill again. So these are areas which have potential to have a significant impact. Now, one of the problems when you're evaluating options is everybody looks at the economics. It's not a problem, but it's just the fact that, with costs, we know, how to do the analysis. We know that the best option has the best NPV or best IRR or these sorts of things. So how do we bring in a second criteria, such as greenhouse gas emissions? So one technique is to use carbon charges. Now, these could be either direct carbon charges. So if the company is located in an area which has carbon charges, then that would be a direct one. Or the company can adopt a shadow carbon charge, where they say, well, we will assume that there is a price for carbon, and we will use that in our decision making. Many companies use different prices, but if I use $50 a ton as an example, this can, on a diesel, if it costs 70 cents a litre, this will basically increase the diesel cost by 20%, and therefore it could have an impact of 5–10% on your mining costs. As many of you will know, that if you have that type of impact, you may then think of alternative solutions, and that is the intention of this. Another technique is to use a marginal abatement cost curve, and this is used quite extensively, especially by companies such as Glencore, where you evaluate a number of initiatives. You then take these initiatives and then rank them according to what is the economic impact. So the best ones go on the left and the worst ones on the right. And then you also then consider what is the impact on the emissions, and that's what is varying across the x-axis there. So as you can see, the ones on the far left, well, they're easy to justify economically. So you're going to do those anyway, and you're going to get a benefit in reducing your emissions. There's a large amount which is marginal, but it does have a significant impact on your emissions. And one of the attractive things about this is these can be packaged up and then be used to source green finance. So there's a number of organizations, whether it's commercial banks or some of the national banks, or the international funding agencies like the IFC or EBRD and so on. They are ready to put money in to support these types of initiatives, which have got significant impact. But people need to be persuaded that it's a good use of capital. And then there's some further ones that could be done when we take into account the cost of carbon. So suddenly you can see that we've moved from about having 20% of the ideas as being passing both economic impact and having a benefit in the reduction of emissions to now around 80% of the potential to reduce emissions through being able to look at the economics in a more flexible way. So, okay, I'm interested. How do I then calculate what my emissions are going to be able to evaluate these options? Well, with your scope 1 is relatively easy because 1 litre of diesel is approximately 2.69 kilograms of CO2. So we often calculate how much diesel we're going to use, just apply another row and put another figure in, and then you have your emissions. For your indirect, it depends on your where you're drawing your power from, because it depends on whether you're being gas powered or coal or nuclear, etc. But you can work out from the grid what it is today, what it's going to be tomorrow, and work out what is going to be the amount of emissions per kilowatt hour consumed. So these are relatively simple calculations that can be done. Yes, there are some more complicated calculations that can be done, especially when you're moving into other emissions. But for most of us, for most of our analysis, this will be able to provide us with a quick answer and quick guidance to take you forward. The next set of bytes are specific to certain industries. So obviously, if you're in coal, then one of the byproducts of coal is methane. So you can, some deposits, you can extract the methane from the coal before you mine it. Sometimes you extract it as you mine it, and sometimes after you've mined it. So there is a lot of methane being emitted. For the underground mines, they have been quite interested in extracting the methane before mining, where it's possible, because of the improvement in safety. But if we now then take into account that this has a significant impact on the emissions, then more effort can be done. Now, not all coal is easy to does not always release the methane easily, and therefore there are a lot of challenges associated with that. However, there are also still a lot of solutions, and the world of fracking has created a new set of opportunities to release that methane and capture it. A number of mining companies are also looking at how they can capture the methane from open pits. Now, obviously, you can't do it in the open pit, but you can do it ahead of the mining. So that is an area which a number of companies are looking at. Certain deposits, the host rock is mafic, and therefore there's a lot of magnesium silicates around. Magnesium silicate naturally weathers to magnesium carbonate. So if you are a chromite, diamond, nickel, PGM operation, and your host rock has a mafic rock, then you've got an opportunity to be able to sequester carbon naturally. So at the Mount Keith operation in Australia, they found that they were sequestering 40,000 tons of CO2 without them doing anything about it. It was just happening naturally. So that was about 50 tons of CO2 per hectare, which is similar to having a forest there. Now companies are starting to look at how to accelerate that process. Do you rework the surface, turn it over to expose fresh rock or fresh tailings to the air? Do you bubble air through the tailings before it's thickened and before you send it to the tailings? Do you vary your beach area? There's a lot of solutions that people are looking at, and this is because this is a relatively easy way to be able to capture the carbon and therefore reduce your net emissions. However, it does require some rigorous analysis in order to be able to account for this. Carbon capture, usage and storage is something which is specific to people who have a point source where there's a lot of carbon dioxide being emitted. So cement manufacturers is one such industry. This is particularly interesting for Europe because we've also got a lot of natural gas pipelines going to old natural gas fields in the North Sea. So this is something which is being adopted in Europe, and then obviously that's helping to bring the cost of this technology down. Moving on to bite number 7. So downstream emissions. I talked earlier about smelting being the large source of emissions. So companies like BHP are looking at how they could fundamentally change the industry. First of all, by moving to a direct reduced iron, which at the moment use natural gas to be able to reduce the iron instead of coke, or they could use hydrogen. And then they've created a feed which is suitable for either electric arc furnaces or ideally an electric smelting furnace. And therefore, obviously, once it's electric, you can then use nuclear power or renewable energies to be able to power that. Some are looking to move from pyrometallurgy to hydrometallurgy. So the Newton Rio Tinto joint venture is looking at using biox to be able to, bio-leaching, I should be saying, to oxidize and help release copper. Similarly, Freeport is also looking at solutions. So what are companies looking to do? So this survey by McKinsey a number of years ago shows that a lot of companies are planning to achieve about a 30% reduction by 2030. Some are looking to have an absolute reduction, and some are looking to have a reduction in the intensity. So the difference there is how it affects your plans for growth or acquisitions as to whether there's a significant difference in these two methodologies. But you can see some like Rio Tinto are being more aggressive. They're going for a 50% reduction. Now, these changes, I think, are unprecedented in the industry. I always learned that the mining industry was a conservative industry, and then suddenly we've discovered that we wish to be an ambitious industry. So these are what a large number of companies are looking at. Specifically, you can see that companies are looking to tackle how they source their electricity. So BHP have had a significant reduction so far with the adoption of power purchase agreements. With the diesel, they're waiting to see the new technologies come in, which they expect will come in more after 2030 to be able to replace that. And then they're also looking at options to be able to capture methane and be able to eliminate that source. As mentioned earlier, they're also looking at this downstream aspects because they noticed that steel making generates 40 times more emissions than the mining and processing operations, and therefore they're looking at how the mining and processing can be adopted or adapted so that way there is less emissions downstream, and that's mainly looking at a conversion from blast furnaces through to direct reduced iron solutions. Anglo, similar, they're also looking at these same areas, and they're looking at different ways to be able to reduce that. So some significant progress made already with plans to achieve even greater reductions going forward. Newmont, again, similar, obviously no methane for them because they as a gold operation. but they are looking at, they've made some significant movements to adopting power purchase agreements and renewable energy. But otherwise, they are looking to, because gold mining has needs a lot of flexibility, they are looking at the battery electric vehicles as being a key solution. But they're also looking at other technologies. So they're looking to adopt existing technologies, but they're also looking at what new technologies are on the horizon and how they can also facilitate that in order to be able to come up with new solutions. So how do we design a low carbon mine? A lot of companies are looking at that. So the Los Azules copper porphyry project in Argentina is looking, it's still at the feasibility study stage, but they are looking to become a zero carbon by 2038. And they've got investors from car companies such as Stellantis who are keen to get zero carbon copper for their vehicles. So the opportunity obviously depends on the particular deposit and where that deposit is. So in some countries where you've got low carbon electricity, then switching over to electrify everything is going to enable you to achieve that aim. Otherwise, you need to be able to focus on how to be able to displace the diesel fuel in the open pits and looking at the different solutions there. You probably need to design for optionality, so it's probably going to be more likely electric drive trucks rather than mechanical drive trucks, as these have got, obviously they can be electrified more easily. There's a lot of investment in technology and understanding, getting information about the details using onboard sensors. Where are there potholes in the road? How can I improve my recoveries? Am I achieving the grind sizes? And then obviously, as mentioned, you can look at your, when you look at options, consider the emissions. And there's also a lot of research, what could you do? And this is an area I think is quite exciting. So in summary, the industry has potential to have a significant impact. There's been a lot of progress made so far. And I think the industry is finding the questions interesting. So, as I said, normally the industry is traditional. So, we don't want to try that. Oh, I don't want that's risky. Now people are being forced to try new ideas. They're actually finding that they're getting a lot of other benefits as well. So at the moment, I don't perceive that there's any reduction in the appetite for change. And I see that there is a lot of opportunity going forward. So I hope you will enjoy that you found this talk useful, and I hope you'll enjoy the journey of discovery. And as I've said, how do we eat the net zero elephant? One bite at a time. So thank you.
Dave, thanks very much. You certainly tackled a large body of knowledge and information and shared it very effectively and efficiently with when I last look, 38 external members on the call. So I really appreciate that. We really appreciate it. Thank you very much. I see there are a number of questions in the Q&A. Can you see the Q&A on your side?
I can indeed, yes.
Do you want to work through them, or?
Yes, I think Aristeo's, hopefully have answered some of the questions as far as is a 30% reduction in emissions by 2030 a realistic and achievable target. I think the answer is yes. I hope that I've shown you that a number of companies have achieved more than 20% reductions already, and that there are plans for further reductions. Obviously, they've taken the easy steps so far, which is to go in for renewable energy. And obviously, in countries like South Africa, there is a big challenge because you haven't fully embraced that journey yet. And then also, in order to embrace that journey, because you've got a lot of potential with a lot of solar and wind potential, but that potential is located in distant places versus where the demand is. So therefore, there's got to be some significant investment in changing of the grid systems. So obviously, this requires people to work together. So it's going to be requiring the companies and the governments to work together. But as I said, when I've been speaking to groups like the IFC, they have money available to facilitate these sorts of changes because they can see that this is valuable. So hopefully that will answer your first one. There's a typical consultant's answer, which is yes, but. For the second question, what extent are mining companies under pressure from governments, investors, and civil society? I think there is reasonable pressure. In some countries, such as Australia, they have announced that they have carbon budgets. So the country has a budget. And if your operation is going to use a significant chunk of that budget, you may find that your project will not be approved. So that has happened to a couple of the coal projects where they've not been approved because companies have said, or the country has said, that you haven't demonstrated how you're going to reduce your emissions sufficiently. Investors there is a certain amount of pressure. However, I noticed that there was a statement from the CEO of Rio Tinto last year, which said, well, they're not seeing a benefit for producing green steel versus black steel, for example, or green aluminium versus black aluminium. And therefore, this is still something which is not as much pressure as there should be. But certainly the banks have been limiting what they have lent to certain sectors, and there is still a view and a pressure on this. So it is a certain amount of pressure, more in some jurisdictions than in others. As far as incentive mechanisms, I think the key ones that are available are mainly with the availability of green finance. So there's been a lot of green finance available from either private sector banks or from developmental banks as well. So that has certainly been tapped into by a number of companies, and therefore they have people have structured their activities. So as I've said, they've taken those chunks which are having a significant impact on the emissions, but need some extra finance to help deliver them to be able to get to make those changes. There are some other changes. So, for example, Rio Tinto has adopted renewable diesel for their borax operations in the States, but that's because California has said you will have zero emissions by a certain date, and that includes your mining trucks. Now, they've trialed the renewable diesel, and they found that it is as good as fossil fuel diesel, and they are making that transition. Fortunately for them, in the States, about 10% of all diesel is renewable diesel. So there is a sufficient capacity on that. Absolutely. So moving on to Cholofelo's question. So the impact of battery electric vehicles on the grid supply. Absolutely, this will have a significant impact, and there will need to be a lot of beefing up on this. You will also need to plan and operate the recharging to be able to suit the grid supply. But that sort of planning is fairly straightforward. You have sensors on the vehicles, you know where they are, you know what the battery limit is, you know what they're going to demand, they're going to use over the next half hour, 2 hours. And therefore, you can come up with a suitable program to say, truck 73, finish this load, and then go and get recharged. So yes, it will have a significant impact. Yes, the grid will need to be beefed up accordingly, but it is something that's fairly easy to plan. So moving on to Paul's question, as far as battery life, this varies quite a lot. So I've seen a lot of things from 4,000 cycles to 15,000 cycles, and I've seen it also for vehicles. They're talking about that they can, so like in your Tesla now, it is likely to outlast the life of the vehicle. So having 400,000 miles on a battery is not a problem. Now, the replacement of these batteries occurs when the recharge capacity gets down to about 80% of its capacity, because it's then requiring recharging more frequently, but also it is making it more, it's not as responsive going uphill and so on. But what there is, there's going to be a second life to these batteries, because if you take these batteries and put these into energy farms, this can now be your battery electric storage system. And this is something that people are looking to do with a number of the electric vehicles, is to move it into these farms, because you can afford to have a much lower rate of or much greater rate of degradation before the battery becomes useless as a battery storage device. So that is then going to provide an opportunity to be able to offset some of the cost of replacing the batteries. So 7,000, 15,000 life, that is likely to be in the region of 5-6 years, so similar to an engine life. So those are the 3 questions that I have seen in the Q&A. I'm not sure if there were other questions elsewhere.
I'm only seeing this one. I would like to comment. I don't see anything in the chat. So in my experience with this post-retirement, I spent 3 years working for a large mining company doing project investment reviews related to their carbon neutrality program. And the broad learnings that I got from it, which I'd just like to share, is to really say that outside of the specific detail that you've shared, which is fantastic and absolutely perfect, is the fact, the mindset that has to go into it is around addressing the challenge holistically. So looking at it from an integrated, adaptive system perspective. So it's a industrial ecosystem in many respects, and an integrated adaptive system. And just your point about energy farms, the opportunity for recycled batteries into energy farms, all of those components need to flow into the evaluation of the options that are identified in the various studies. The other one was...
But those options, as you said, yeah, absolutely, it has to be this holistic, but they're not particularly difficult.
That's true.
So it is, yes, you have to look at what your grid system is capable of doing. Yes, you have to look at whether your mine planning needs to change and so on. But none of these are particularly difficult ones. And I think that, it can be done, and a lot of operations on site, a lot of people can work it through. They just need to understand what is the impacts and what are the benefits, and then say, okay, we can do it. We're not going to be able to do it for 2-3 years because the next cutback is not going to be starting until then, but we need to develop it at this particular time. We're going to need to make these changes with our equipment procurement. We need to go to do this. All of these are straightforward actions, but they do need to be planned and thought about in advance.
Absolutely. The other point which we briefly chatted about when we were setting up this webinar was the importance of acknowledging the specifics of the ore body and the location. This particular group I was working with, a solution which is appropriate for Africa, would not work in Latin America, and equally is less attractive in Australia, using 3 very sort of center, east and west locations. And that goes to the nature of the renewable energy, it goes to the infrastructure, it goes to the legislation, it goes through multiple factors. So one size doesn't fit all, and being able to acknowledge that is also really important.
Absolutely. No, it's a site by site analysis, but we are using common solutions, and a lot of these solutions are proven solutions. Now, obviously, there's a lot of new technology being evaluated and being developed. So people need to be aware of that so that you can design to future-proof sounds negative, sounds like you're defending against things, but say maybe future opportunity to be able to say, well, I've bought electric drive trucks, and therefore I can then move to trolley assist in 3 years' time when the next cutback comes available. I can then move to putting in hydrogen or battery trucks when the grid system has been upgraded, when the renewable plant has been commissioned. So you can take these steps going forward, but absolutely, it is a very site-specific one, not just country-specific. So even within one set of operations in the Northern Cape, you're going to have different solutions depending on those sites.
And then the other one, just as a closing comment, and it might sound a bit trite. They always say that the data will set you free. I found my biggest friend, in inverted commas, in this whole process was fully understanding that marginal abatement cost curve, and inside that, the focusing on the projects that were technically less challenging, but were the easiest to implement, that gave you the fastest return, that built confidence in the work that was being done. Because often this elephant you're talking about is seen to be so big that people don't know where to start. But being able to get the focus, an intellectual focus, a financial focus, and a energy of movement in the system, getting people to deliver, the marginal abatement cost curve was definitely one of my biggest allies.
Absolutely. Change management has always been about getting quick wins. Prove that the concept is valuable, delivers benefits, and then you've got some money in the bank to be able to take the next initiatives. I see we have a question from James Brown. So as far as the future of offsets, this is not this is an area which at the moment people are trying to avoid relying on. And this is where people are expecting will be an important part of the getting to the net zero by 2050, but are not part of the steps in getting to the targets for 2030. There's a lot of issues and concerns about the reliability of these offsets. And there's still a lot of money in this area. There's a lot of companies who are demonstrating that they're producing good solutions, good techniques, which are capturing carbon, are reducing carbon, and therefore they can claim offsets. But as far as the targets at the mining industry, and as far as the 30% to 50% targets for 2030, they are not really part of those initiatives. Carbon sequestration, either in carbon capture or in the weathering, is the one is the one exception to that, where people are able to demonstrate that this is happening and it is permanent. So I hope that answered your question, James.
Thanks, James, for that question. Right. I think at that point, David, unless there's a last minute question from anybody else, I'd like to wrap it up. And right up front, I just have to thank you for your time, the effort you've put into this, the time you spent with me, and the informative presentation and discussion that's come out of it is really crucial. So thank you. Thank you to all the attendees who are online. I recognize a number of the people on the call. I won't call you out, but there's some fairly deeply involved people who understand this space well. So thank you for your participation. Do appreciate that. Overall, to David, thank you, and to all the attendees. The SIMM really appreciates your support. And as some of you would have seen who logged on earlier, there is a whole program of SIMM webinars ongoing. So if you go to the SIMM website, so it's obviously www.saimm.coza, you can find updates on all the webinars, training schools, and upcoming conferences. We'd love to have you on future activities, David, if you have a chance. And when you are next in South Africa, please, we must arrange to have a glass of wine together.
I look forward to it.
Good to have some face-to-face.
Yeah. I think a key point is that a copy of the presentation will be available. So for those people who want to go back to refer to any of the points and facts and figures, and obviously it is being recorded, and I assume that a copy of the recording is available. So should anybody wish to share the presentation with people who were unable to attend, then they can do so.
Right, thank you. Thank you, Nestle. Thanks, Katina. And to everybody on the call, please take care. And in everything you do, stay safe. See you again sometime. Thanks a lot. Cheers.